Now it's my turn to show you around the geometry garden. My name is Escher, and I was a Dutch artist in the 20th century. Geometry was a constant source of inspiration for me. I'm a past master in the art of drawing fantastic tilings. Look at this self-portrait in a spherical mirror. One of my most famous drawings shows lizards drawn on a plane that managed to break out of the paper. Now, perched on high, they contemplate their previous existence as flat life. To prepare ourselves for life in 4 dimensions, we are going to use the ideas behind both my engraving and a little book published at the end of the 19th century by Edwin Abbott, an English clergyman, called Flatland. Let's try to explain to these flat beings, these creatures live trapped forever in a plane, what our everyday life in 3 dimensions is like. Let's imagine that one of these lizards manages to escape his miserable existence for a moment and climbs out and up onto a viewpoint looking down on his world. How would he explain to his fellow reptiles the existence of objects in 3 dimensions? As a first attempt, he could try to pass some 3-dimensional objects through his flat world. Here, for example, is a tetrahedron with its 4 faces passing through the lizard's plane. The flat creatures see a green triangle appear suddenly, then gradually shrink away. This is all they see, since their senses are entirely restricted and they cannot perceive anything outside of their plane. Each time that the lizards see these green polygons appear, change shape, and disappear again, they might imagine the form of the object that has just crossed their plane. To see how hard it is to visualize the form of a geometric body from its cross-sections, try to guess what is crossing through the plane now. A tetrahedron. And now? It was a cube. Of course, you have to remember that these lizards don't have the same perspective we have. All they see is a sequence of polygons, and they'll have to develop an understanding of depth in order to fully appreciate the shape of the body. And now what? An octahedron with its 8 faces. And an icosahedron. It's a solid with 20 faces. And finally, the dodecahedron, 12 faces, 20 vertices, and 30 edges. Now we're going to show you some cross-sections, and only cross-sections, and you have to guess the polyhedron hiding behind them. That was a tetrahedron. That was a cube. It's getting hard, isn't it? You see now that these creatures stuck in 2 dimensions have to develop good geometric intuition if they want to understand something of the 3rd dimension that we take for granted. We'll have just the same kind of problems to get a feeling for the 4th dimension. Here's a second method to explain polyhedra to our flat friend. Start by inflating a polyhedron so that the vertices and the edges are on the surface of a sphere. Then we stereographically project onto the plane of the lizards so that our 2-dimensional friends may enjoy the spectacle. Of course, we can spin the sphere around, and with it, our tetrahedron, just as we did before with the Earth. Let's take a look at the cube and see how many vertices, edges, and faces it had. And now, here comes an octahedron. You see the 8 colored faces? Look how the projections of the edges are arcs of circles. Now here comes an icosahedron. Its structure is more complicated, but it's not hard to understand, even for the lizards. One can see 20 faces, 12 vertices, and 30 edges. Can you count them all? Finally, here's a little geometric jewel, the dodecahedron. Now for some exercises. Let's take ourselves down into 2 dimensions and try to recognize the polyhedra from their stereographic projection. It's easy, isn't it? You can see the 4 faces, 6 edges, and 4 vertices. There. It's a tetrahedron. Now, what's this one? 6 faces, each with 4 edges. That's right, it's a cube. That was harder, wasn't it? The faces are triangles. 5 edges start out at each vertex. There are a lot of faces, perhaps 20. It's an icosahedron. Well done. Let's look at the dodecahedron. Each face is a pentagon. If we count them, there are 12 faces. 3 edges start at each vertex. These 5 solids have always fascinated geometers. The Greek philosophers attributed a magical importance to them by associating one of the fundamental elements from which the world is formed to each of them. We call these figures the Platonic solids. So we agree then. It's not easy to get a feeling for the 3rd dimension when you are flat. There is more than one way to do this, but our stereographic projection gives a good idea of what's going on. Now, let's get ready for the 4th dimension. Prepare your imagination for a workout.